Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over a specific concept called the normal distribution. And before I start on this video is specifically dedicated to one of my students who's sort of having a little trouble on this concept, and I tutor him for AP Statistics. And so for you, this is the video for you, okay? And so when I am discussing this concept around normal distribution, let's just get it straight out that a lot of times when we're doing normal distribution, it's going to be in the idea that it looks like this. So sometimes we'll call it bell-shaped sort of graph, sometimes we just call it the normal, whatever not, okay? And so based on the questions, like based on the word problems, they might involve this sort of, thinking. And so when we are doing this sort of calculations and or whatever not that's involving normal distribution, we have to understand that whenever we discuss normal distribution and whenever we are dealing with certain percentiles or mean values and whatever not, we are going to be encapsulating this idea within the context of the z-score, okay? Because z-score will only exist if it's within a normal distribution. You cannot use z-score if it's not in a normal distributed format. And so the z-score formula usually exists as the observation minus mean over standard deviation, okay? And this z-score rule could apply to anything. It could be based on proportions, it could be based on distribution, which I'm focusing on today, but be aware that this general rule around z-score will exist like this. And the purpose of a z-score is to prove whether or not a certain percentile exists within a range and whatever not, okay? And so when we discuss z-score, the definition of a z-score is the number of standard deviations away from the mean, okay? And so a lot of times we have to be very careful to work with the z-scores and whatever not, because when we get z-scores, in the end, our purpose for z-scores, when we find z-scores, and I don't want to move it too far, but the idea is that when we get z-scores, a lot of questions work between the z-score values, and which it also involves quote-unquote the mean value could exist because of the equation right here. It could involve observation values when you do annotations or whatever or not. It could involve standard deviation. And then usually not, whether or not it's going to be between z-scores and percentiles. So if you're given like the fact that, oh, the population is 80% under this curve, or 50% of students score lower than this score or whatever not, this is what we're working between. It's always going to be sort of like a pull and push relationship between z-score and percentiles, especially when you are discussing in the context of the AP Statistics examination. So a lot of times whenever I see problems or word problems that discuss these type of concepts, I keep it in my mind, this sort of relationship that exists. So that, for example, if I see percentile, okay, well, I'm going to most likely have to find something in the z-score. Or if I'm given a lot of this information here, okay, well, I got to solve it out and go to percentile. Okay, and so the functionality that lets me go from z-score to percentile, for example, will be based on the calculator in this function called the normal CDF. Okay, this is a wonderful function that can help you switch over to percentile. There is another method where you could use the z-score chart, but for the focus for today, I'm mainly going to be focusing on the calculator functionality when it comes to that case. But let's say you're given a percentile and you're given some info and you need to find one of these. Most likely, you're going to be ending up using a calculator function called the inverse norm. Now, I do want to explain the breakdown of these, functionalities, and then go into a problem where I'm going to do the problems with this, sort of working through this and show you with these functionalities. But a lot of times, this is how I think of inverse norm and normal CDF. For inverse norm, when I punch it in, could only be punched in as a percentile value. But I do want to note that when I mean percentile, it's going to actually be in the decimal format. So for example, if I tell you that, 80% of people are below the curve and whatever not, that means I need to put 0.8. But be aware that inverse norm can only be based on a left-hand behavior. That every computation I plug in, whatever the x value is always going to be to the left-hand side of the normal curve. And so make sure you understand that there is a limitation to this. And that if you cannot find it, let's say it's 20% above right here, that it's going to be the equivalent to the 80% below. Okay, and so I just wanted to note that. When we talk about normal CDF, we can adjust between left-hand behavior or finding left area or the right area to get to the percentile value. And so a lot of times normal CDF, at least when I teach it to students, I usually teach it in the context that it's going to be negative 999 comma the z-score. If I want to make this, so this is in relation to if I want to make it like this format, where it's, the left-hand side, I shade it, woohoo. Okay, another way I could punch into the calculator to get the necessary values is that I'm going to put z-score, comma, 999, and it's going to look something like this, where I could get the right hand behavior. And so it is a little bit more flexible. You just need to make sure to remember that this is the sort of functionality that does exist when we are dealing with the sort of normal CDF functionalities of the calculator. But that being stated, I do want to get into maybe one or two examples based on this concept of normal distribution and show you what I mean by all of this, okay? So make sure you have taken notes on this concept or, remember this sort of concept and, make sure to follow along as to how this functionality, these sort of, this work that I'm doing here does connect back to the questions that I'll do for you. So I'm going to read you a question and I'll write down or paraphrase it a little bit around what the problem's on, and then I'm going to explain to you how I was able to solve it out. Okay, so I'm going to read this question. So it states that an individual from Harvard University, was quoted in a news article or the Crimson article as arguing that the average life expectancy to reach 100, 18% of these people will have lived to 120. So 18% of these people, that's what they're arguing. So 18% of these people reach to 120 years old, and that the average life expectancy is 100. So that means my mean is going to equal to 100. So 100 years, so right here years, 220 years, whatever not, okay? And so afterwards, they're asking me, what is my standard deviation is the individual assuming is correct? So for example, I don't know my standard deviation. I'm wondering. Okay, so the part is this. As I mentioned before, and I'm going to redraw that sort of chart system, the z-score, and switching to percentile and between each other's and percentile, there are a few things that I need to know. Well, for z-score, as I mentioned before, I need my observation for the equation. I need my mean, right? And I need my standard deviation. And I'll write them all down. Okay, perfect. And and for percentile, it's just a percentile value. And I look right here, whoa, perfect. There's a percentile value they give me. So my percentile value is going to be 0.18. That means I need for certain inverse norm for this question. There's no question about that. Okay, well, I'm looking at this and they say 18% will be 120. My mean's 100. So this is 100 for certain my mean. Standard deviation, I don't know, because I just mentioned right here, right? And mean is, and what happened right here? They mentioned that after 18% of them will be 120 years, right? So that means my observations could be 120. And so my idea behind this is the fact that, well, if I set up the z-score formula, it's going to be observation, so 120 minus your mean, 100 over standard deviation, which I don't know. I'll just put the standard deviation symbol or question mark, it doesn't matter, equals to the z-score. But I'm not given the z-score right now, which is going to be the problem right now that's going to stop me from solving this properly. But if you notice also, I have percentile and I have the percentile value of 0.18. What's so significant about this is that if I do inverse norm, it's going to give me my z-score value for this question. And so what I'm going to do now is that I'm going to get my TI-84 and show you how I'm going to go about doing that. So showing on my TI-84, let me check that out right now. So to do that, okay, what I'm going to do, as I mentioned, was the inverse norm functionality. And that's going to be under second. I'm going to go ahead on my calculator, push second, go to vars. And what's going to happen is on number 3, there's a function called inverse norm. And I'm going to punch 0.18 because they did mention that, and it's going to be this value. But that being stated, I'm just looking at the question. It states that 18% will live up to that value, right? So that means that if I punch this in, this is going to be equal to negative 0.9154. And I do also want to side note that not always is it for certain that it's going to be negative or it's going to be positive, because based on the scenario, it could be the positive version or the counterpart of it, but that doesn't really matter because later on you'll see what happens when I manipulate this equation. And so for this question, I'm going to go ahead and switch around these. So what I'm going to do is I'm going to switch these two because the cross multiplication rules do allow me to do that, where I could do this. Okay, and I'm going to end up doing is 120 minus 100 divided by 0.915360. I could put the negative in, but I just decided not to. So because it's standard deviation, I know it's going to be actually a positive value, and so it's going to actually just be 21.84 or 85, and it is the actual answer for this question. So be aware that especially standard deviation, there's no such thing as a negative standard deviation, just because standard deviation is a concept of space between numbers. And so just be aware that sometimes when I do inverse norm, it could be the opposite symbol value dependent on the scenario that I'm given. But that being stated, this will be my answer as to how I was able to get to this answer, or how did I get to this standard deviation, which I was looking for. And so a lot of times when we're dealing with these z-score or normal distribution based questions, it's all around you being able to be flexible and knowing, not just knowing the equations and just plugging in basic values, but understanding how to manipulate these equations in order to be able to solve these questions out. Okay, and so be aware that this is sort of the premise around normal distribution. I do want to do maybe one more question on this concept just to make sure that you're all good and understanding how to go about doing these questions. So I'm going to do one more question based on normal distribution. And so yeah, so I'm going to go ahead and do so. So let's say that we were given a scenario that a plant, just like a random plant on a farm, has a standard deviation of 2. So a lot of times when I'm reading this, I do annotate this and write standard deviation equals to 2 because the plant has a standard deviation of 2. And what is the mean weight? So I don't know my mean weight. That's what's telling me. If 85% of the cucumber, so 85% of these, weigh less than 16 ounces, okay? And so for this question right here, I can see right off, once again, z-score and percentile is going to be in play right here. Okay, because I see whenever you see a problem that has a percentile value, I know almost always will it be the case that I have to deal with inverse norm in some sense, especially when it's normal distributed. And so for this question, 0.85 for certain is going to be my percentile. Once again, I know my mean is unknown. My standard deviation equals to 2. If I'm looking for observation, or aka I could actually write it as a symbol of x bar like this, which is my observation, is going to actually be, it looks like 16. Okay, so that's my observation. And so using the formula once again for z-score, observation minus mean over standard deviation, it's going to be 16 minus my unknown over 2, which is going to equal to my z-score. And duly note, I'm going to write z-score below, but that being stated, the z-score is going to be whatever I get out of the inverse value of 0.85. And since it's less than 0.85, I know the fact this is going to be an accurate value when I do inverse norm. So going ahead and punching it in. So once again, yeah, here we go, 0.85. It's going to be 1.0364. 1.0364. And so to solve this, once again, I'm going to have to multiply 2 and move it around. So first things first. So I'm going to multiply 2 on both sides. So what's going to happen is that times 2 is going to be 2.072, basically 9, rounding off a little bit, will be 16 minus question mark. Okay? And so afterwards, I could subtract 16. This is more algebraic than statistics at this point. So my 16 is going to be negative, but this is also negative. So my question mark is going to end up being around 13.93. And that is sort of my mean sort of weight for this plant, for this scenario. Okay? And it sort of makes sense because if my observation is 16, that means my mean has to be most likely nearby that value, chances are. Not always is it the case, but well, chances are it's going to be nearby some of the cases. And so this is sort of my explanation around the concept of normal distribution. Thank you so much for watching this video. I do plan on making a new video soon enough around different concepts such as the 689599.7 and so rule. So make sure to subscribe to this YouTube channel or like our Facebook page so that we can continue to make content like this. I hope you have a wonderful day.